Okay, we're on day 2 information. This is the first lesson of 2 lessons on day 2. And what we're looking at is a kinematics review. Now, kinematics is the study of motion. This will bring back some bad memories from some people from grade 11, but remember this is open book. So you take good notes, have everything organized, and you're going to be fine here. I'm going to show you the formulas you're going to need. I'm going to talk about what you need to know, and I'm going to go through one problem. First thing, in grade 11, you probably did significant figures or significant digits. We are not going to be using those in this course. One of the problems with significant digits is you focus so hard on that concept that you miss some of the physics concepts that are important. And I don't want to mess around with what you learned in grade 11 about this, so we're going to leave those out. So just do the problems. You will have 2 activities at the end of this lesson. You will have U1A3 quiz and you'll have U1A3A2 assignment, which is just 2 problems to try and see what you can do. Now remember, we have formulas for speed. Remember, speed is scalar. It doesn't have a direction. And then we have 2 formulas that do have direction involved in them. They're vectors. It's velocity and acceleration. So speed is distance over time, velocity is displacement over time, and acceleration is velocity over time. Now the problem with these formulas is people try and use them when we shouldn't be using them in physics. And I'll give you an example. Anytime that something is traveling in the vertical, we must use these formulas right here. Write them down. Have them handy. We use these in the vertical, so if we're kicking a ball up in the air, if we're shooting a cannonball up in the air, we must use these formulas because they have acceleration due to gravity in them. This last one does not, but you can use it under certain circumstances, and that's to find time if you do know VI and VF. So you can use this one when you need time, when you do have VI and VF. If you want to find time using these 2 here, you've got quadratics you have to do, so it makes it more complicated. I'm going to run through one of the example questions that they give you just to give you a background on this and let you know where we're coming from. So what they talk about in the problem is that there is a person standing on a cliff and they throw a ball upwards at 15 meters per second. So this is V initial right here, and it's positive. Anything going up is positive, anything going down is negative. So the ball's going to go up, it's going to come back down, and they say it travels down 15 meters to the person who's down below. Now, notice the symbol delta D, change in distance. The change in distance is from here, from the person to the bottom. You don't include all of this up here because a change in distance is defined from where you start, that's where we started, to where we ended. And it's going down. So if it's going down, it's negative 15 meters. Now, our acceleration is also going down. Make sure you put in the signs where needed because they will be important. Negative 9.8 meters per second squared. Okay, so it's important to understand certain things. If you're throwing the ball up, it's a positive velocity to start with. It'll be a negative velocity at the end because it's coming down. Our distance is negative because we're going down, and our distance is the distance from where we start to where we end. Now, there's more than one way to get the right answer. So you can use any formula you want that has final velocity in it where you have everything else that you need. So I'm going to use this formula right here. VF squared equals VI squared plus 2AD. And I'm going to use this formula because I've got all the information I need and it's easy. I've got 15 squared plus 2 times negative 9.8 times negative 15. So I'm just going to do the math there, and I'm going to take the square root of that, and I'm going to get 22.8 meters per second. Now this is going down, so I'm going to call this negative. I'm calling it negative because I know from my diagram that it's going to be going down. Now, some students have said to me in the past, hey, the final velocity is 0. When it hits the ground, it's 0. No, when they say final velocity, they mean right before it hits the ground. So that's the first part of the question. The second part of the question is they ask you to find the time that this takes. So I'm going to set up a formula. I like to find my VI and VF so I don't have to mess around with the quadratic. The other thing you can do is there's quadratic calculators out there where you do a search for quadratic calculator, you put your A, B, and C in, and it'll give you the final answer, and you don't even have to do the quadratic. But I am going to do this, VI plus V final, and that's delta T. I'm going to rearrange this formula, so delta T equals half VI plus VF over, did I do that right? Yes, I did. No, I didn't. Sorry about that, folks. It's delta D over half VI plus VF. There we go. I apologize. Now, here's the trick. Your delta D is negative 15. Your VI is plus 15. And then you've got to subtract 22.8. And the reason you have to subtract is because that's negative. So it would be 15 minus 22.8, multiply that by 0.5, and then divide minus 15 by what you get down here. And you will get time equals 3.8 seconds. Folks, there's a couple of example problems. As you go through the content, go through these a couple of times. Make sure that you've got that straight. Make sure that you've got all of your formulas written down in a convenient area. And remember, we use these when we're going straight up and down, okay? Because they have gravity in them. So that's where they're important. Good luck.